let us see some questions of MSET. So first question, which is of MSET 2018 from paper 3. The question is the value of delta square by E bracket of x square taking h is equal to 1 is, options are -1, 0, 1 and 2. So how we will see what is the value. We have delta square by E of x square. So we can make it as delta square E inverse of x square. So first applying E inverse to this delta square E inverse of x square. So what we have, so E of f of x will be f of x plus h. Likewise E inverse will be f of x minus h. So here they have given h is equal to 1. For h is equal to 1, E inverse is f of x is equal to f of x minus 1 for h is equal to 1. Now f of x is equal to x square, we are having x square. Now E inverse of f of x will be x minus 1 whole square. So this is delta square of x minus 1 whole square. So for this x square minus 2x plus 1. We have a result. If suppose we are having delta raised to n of the polynomial which is of degree n, nth degree polynomial, then the result is the coefficient of the nth term a n x power, if suppose it is a n x power n minus 1 x minus 1. Likewise this is a naught. Then the result is a n into h power n into n factorial. So here a n is 1 into h power n means h is 1 power n is 2, 1 power 2 into n factorial, n is 2 factorial. So this is equal to 2. Therefore the value of delta square by E of x square will be equal to 2. Option D is having the value 2, therefore the correct option is option D. We have to remember two results here. Delta power n of the polynomial of degree n this is equal to a n into h power n into n factorial. H will be given, so which is step length which will be given in the problem. And one more result we have to remember is E of f of x is equal to f of x plus h. So for E inverse this is equal to f of x minus h. So with these three identities we can solve the given problem. We will take next question, which is also from MSET 2018. The cubic polynomial which takes the following values, some tabulated values are given by Newton forward interpolation formula is. So they have given a set of tabulated values for x and f of x. Here f of x is y is equal to f of x. They asked the interpolation formula, means we have to find the cubic polynomial using Newton's forward interpolation formula. Since the values are x0, x1, x2, x3, this is y0, y1, y2, y3. So we are having x3, therefore the polynomial will be of degree 3. First we have to write Newton's forward interpolation formula. So for Newton's forward interpolation formula we have f of x will be equal to y0 plus p into delta y0 plus p into p minus 1 by 2 factorial into delta square of y0 plus p into p minus 1 p minus 2 by 3 factorial into delta cube of y0 and so on. So here what is p? For the forward interpolation formula, p is equal to x minus x0 by h. Here h is the step length which is nothing but the difference between consecutive x values. Here we can see, so x0 is 0 and x1 is 1. So difference is 1. For x1 x2 the difference is 1. So this is a equally spaced interval. So therefore we are applying Newton's forward interpolation formula. If the interval is not equally spaced, we will use different formulas. So therefore they have mentioned forward interpolation because the reason that the intervals are equally spaced. The values of x are equally spaced. So first we have to find the Newton's forward difference table. So that is x, f of x, so remember what y, 0, 1, 2, 3, 1, 2, 1, 10. So first difference are y0, second difference is, third difference, delta y, delta square y, delta q y and so on. So first difference means this is y0, y1. So y1 minus y0 is first difference, this is 2 minus 1 is 1. Likewise this y2 minus y1, this is minus 1. So this is 9. So for second difference, this minus this is minus 2, this is 10, this is 12. So first difference are 1 minus 1 9, second difference are minus 2 10, third difference is 12. Now substituting, this is nothing but delta of y naught, delta square of y naught, delta cube of y naught. The first sentence will give this is delta of y naught, delta square, delta cube. Now f of x will be equal to y naught plus p means x minus x naught is 0. Here x naught is 0. X by h. What they have given? H is nothing but step length is 1. So x1 minus x naught, x2 minus x1, x3 minus x2, they are all equal to 1. Therefore h is equal to 1. So x minus 0 by 1. So nothing but x. We take it as x only. X delta y naught plus x into x minus 1 by 2 factorial into delta square of y naught plus x into x minus 1, x minus 2 by 3 factorial into delta cube of y naught, because we are having up to third differences. Now substituting the values, y naught is nothing but 1, delta of y naught is 1 plus x into x minus 1 by 2 factorial means 2, delta square is minus 2 plus x into x minus 1, x minus 2 divided by 3 factorial into delta cube is 12. So this is equal to 1 plus x plus this 2 goes, so we get minus here, minus of x into x minus 1 plus 3 factorial is 6, 6 to 12, this goes to 2, 2 into x minus 1, x minus 2. So this is equal to 1 plus x minus x square plus x plus 2x into x square minus 3x plus 2. So again simplifying, 2x cube minus 6x square plus 4x. So this will be 2x cube. So 6 square minus x square is minus 7x square. This is 4x, 5x, 6x plus 6x plus 1. The polynomial is 2x cube minus 7x square plus 6x plus 1. So this is found in option B. Therefore the correct option is option B. So likewise we will find the asked polynomial using the Newton's forward difference formula. So we have to remember the Newton's forward interpolation formula. So how we write? If suppose data is equally spaced, and is forward interpolation Newton's forward difference formula is given by, how we write, this is y is equal to y naught plus p into delta y naught plus p into p minus 1 by 2 factorial delta square y naught plus p into p minus 1 p minus 2 by 3 factorial into delta cube of y naught and so on. Here for forward interpolation p is equal to x minus x naught by h, where h is step length which has been obtained from the given data. So how the data of x, how the x values are spaced, that it gives step length. For the four difference table, the x, y, x naught, x1, x2, so on, xn. This is y naught, y1, y2, so on, yn. Here first difference is delta of y. This is y1 minus y naught. This is y2 minus y1. Likewise, yn minus 1. For second, delta square of y. So y2 minus 2y1 plus y naught. So likewise we follow second difference and third difference, so on up to n differences. So this is for Newton's forward difference formula. So next question, which is from MSET 2019. The question is, the first approximation of the root lying between 0 and 1 of the equation x cube plus 3x minus 1 is equal to 0 by Newton-Raphson method with initial approximation x naught is equal to 0 is, options are 1 by 2, 1 by 3, 1 by 4 and 1 by 5. So they asked to find first approximation using Newton-Raphson method. So from Newton-Raphson method we have the n plus 1th approximation is xn plus 1 is equal to xn minus f of xn by f dash of xn. So for first approximation is equal to 0, then x1 is equal to x naught minus f of x naught f dash of x naught. So f dash should be found with the help of f of x. Here we have f of x is equal to 0 is x cube plus 3x minus 1 is equal to 0. Therefore f of x will be x cube plus 3x minus 1. So f dash will be 3x square plus 3. So substituting this, x1 is equal to x naught minus x naught cube plus 3x naught minus 1 by 3x naught square plus 3. So they have given initial approximation as x0 is equal to 0. So putting x0 is equal to 0, this is 0 minus 0 cube plus 3 into 0 minus 1 by 3 into 0 square plus 3. So this will be, so 0 minus 1 by 3. So this is equal to 1 by 3. The first approximation using the Newton's Rapsell method is x1 is equal to 1 by 3. So correct option is option B. One more question from MSET 2019 only. The question is, for a given initial value problem, y dash is equal to 1 plus xy with y of 0 is equal to 2. The value of y of 0.1 by Euler's method with h is equal to 0.1 is, options are 2.1, 2, 2.2 and 2.4. So here they asked to find the value of y at the point x is equal to 0.1 using Euler's method. First we have to know what is the approximation for Euler's method. For Euler's method we have Euler's method. We have yn plus 1 is equal to yn plus h into f of xn comma yn. Here h is step length which is given here. So h is step length is 0.1. So h is 0.1 means I am going to find that 0.1 only. Therefore for n is equal to 0, this is y1 is equal to y0 plus h into f of x0 comma y0. Here y of 0 is equal to 2. This implies y of x0 is equal to y0. Therefore x0 is 0, y0 is 2. Also h is given, h is equal to 0.1 is given. Therefore y1 will be, y1 is equal to y0 means 2, h is 0.1. f of x0 comma y0 means x0 is 0, y0 is 2. This is 2 plus 0.1 into, here f of xy will be 1 plus x into y. So x0 y0 means 1 plus x0 is 0, y0 is 2, equal to 2 plus 0.1 into 1, 0 into 2 is 0, is equal to 2.1. Therefore the value of y at the point 0.1 is 2.1. The correct option is option A. So what we have to remember is, we have to remember the iteration formula for Euler's method. So this is the formula for Euler's method. Next question, which is a question of MSET 2020, which says, let f of x takes the values y0, y1 up to yn for for x0, x1, x2 and so on xn. Then the value of integration from a to b f of x dx is given by, which is by trapezoidal rule. They asked to find what is the value of the integral f of x dx using the trapezoidal rule. So trapezoidal rule, suppose x, y, this is x0, these are tabulated values, yn. Then for trapezoidal rule we know that the formula is h by 2, y0 plus yn plus 2 into y1 plus y2, so on, yn minus 1. So that complete. So this is the formula for trapezoidal rule. So this is, they have asked directly the formula. We will check with the options. Option 2 is same as the formula we have written. Therefore the correct option is option B. So in order to calculate anything, just we have to know the formula of the integral value using the trapezoidal rule.